Do we have other questions? Do we have other questions? Now, we still have Tuesday and Thursday. And if it's going to be low intensity like this, you know, we'll be annoyed. Today I have some other entertainment for you. So, yeah. If you don't have questions, do you have questions?
Do you know stuff?
Certainly I can go over that.
Permutation groups?
Permutation groups. Okay. So permutation group, by definition, is a subgroup. If we're talking, let's talk about only finite groups. By the way, you made some mistake, not all of you, but when you were asked to describe groups, but we already talked about it last time. When we asked to describe all groups without proper subgroups, some of us jumped to conclusion that group is finite, which was not given to you. You remember it now? Okay, so it turns out that infinite group, so one thing is very simple. If you have a group without proper subgroups, it must be cyclic. And then how you are rejecting infinite, because infinite cyclic, isomorphic to Z has a lot of subgroups. Doesn't work. So after that we have finite and what? Okay.
Quick question. We were talking earlier about like isomorphisms, you know, if there's two groups that are isomorphic, then for a lot of intents and purposes they're the same. Is that if one of the groups has subgroups and things, does the other
isomorphic is the same. If it has subgroups, it also has subgroups.
The same subgroups.
Isomorphism carries through. If you have a group and here you have a subgroup and this one is isomorphic, so wherever this one carried by isomorphism is also a subgroup. If it's normal, it stays normal. You know, if it's centered, it stays centered. All properties are preserved.
Wow.
Okay. So what was it? What are permutation groups? By definition, any subgroup of symmetric group is permutation. Now, what is symmetric group? All bijections of a given set. And here it's, by the way, not important. Finite set, infinite set, all bijections. Now, when you have infinite sets, then it becomes a little bit hairy because you can have sort of competing definitions. What kind of bijections to look at? For infinite groups, for infinite sets, sometimes people are looking only at bijections, which involve always only finitely many elements. Okay. Okay. So these are permutation groups. Now, what Kelly's theorem tells you is that any group is a permutation group. So to be precise, any group is isomorphic permutation group. And how are doing it? By forcing group elements to act like bijections on a set. That's what we did. And what we choose for it, we took group itself and used group operation to produce this bijection. Any element G in G produces a bijection of G. It takes element of G, H, and it sends it to element GH in G. Here is bijection, which is related, completely determined by this element G. So with every element G, you can relate this bijection. G corresponds to bijection, which we call phi of G. Phi of G computed on H is GH. As we know, this will be a bijection, very easy to check. And this is kind of natural bijection. And because of that, mapping like this is a homomorphism from your group to bijections. Okay. Say if instead of this bijection you will take this bijection, it won't be a homomorphism. It will be what is called anti-homomorphism. Never mind. So you have to be careful. Now, there was a pesky problem which you were very unhappy with, namely that any group is also a subgroup of JLN, of matrix group. But proof is exactly sort of, description of it is sort of the same as this one. You're forcing your group to act on vector space, not just on any set. And what is this vector space? It is vector space in which elements of G are basic elements, are bases. So your vector space is all linear combinations of these basic vectors. And action is exactly the same. You just perceive now elements of your group as basis of some vector space. And then it's exactly the same, and then the proof is exactly the same. Okay. So that's what it is. Groups are better understood, not as abstract sets with operation, but as bijections of some sets with some additional structure, preferably. The more structure is in this set on which they are acting, the better understanding of a group which acts on it you can achieve. So standard thing is action on vector spaces. Vector spaces are nice structure, and that's your GLN or whatever. So that's why, so once again, in a nutshell, Kelly's theorem, any group is a permutation group. Okay, who will bring it at some point to the department? Are you familiar? You can do it. Okay. So let me put it on the board, some information here. Thank you. Let me put some information on the board. This is some stupid ritual we're supposed to be involved in. Well, it's not so stupid, by the way, because sometimes there's some reasonable inputs. You have to realize, and let me repeat it, that you should write what you think, not what you think will please me, and be absolutely sure that you won't have any repercussions for it, even if you write some nasty things, for several reasons. One of them is that I will see this without your names. About half a year later, then I give you grades. So don't worry. Also, you understand I would be unable to figure out who wrote what, because I don't have such a wonderful memory as far as your handwriting is concerned.
I trade your memory for my memory.
You will make a big mistake. It would be much better statement, I trade your understanding for my understanding. That would be a good. My memory is not good. My memory is not good. Okay.
I'll take
So let me put something. You all know, I hope, that this is MAT-5420. How about that? Is it? Yay! Now there is a reference number which I think goes there somewhere. Does it or doesn't it?
Well, we have course number and call number. I never remember which one's which.
Okay, so this is called section number. Do
we have
you know
course.
my name?
Course number.
Okay.
So 2, 10, 10, whatever. Section number probably I can write it, but I don't think it. Number of enrolled, you don't need it. This is winter 13, you know it, right? And my name, that's probably you need somebody.
How do you pronounce your first name?
How do you want me to pronounce? As people here pronounce it, or as it
Both.
should be pronounced?
Both.
Leonid. It's as the way it should be pronounced, and Leonid would be in this country.
Leonid.
Say here, it's okay, I'm confused. Makar Limanov in original language, or Makar Limanov here?
The emphasis is different.
Everything is different, by the way. Sounds are different. It's not, I sort of improved with age, but still my sounds are not quite what they should be. And I think my consonants are more or less okay, but my vowels are still wrong. Have fun, and I'll see you on Tuesday, and let's try to have profitable meetings. Bye-bye.
Bye.